Yes, hello. How are you? I hope that you are doing fine, and I hope that you are ready to learn with me in this video, in which we will be talking about our adrenal gland. So, without further ado, let us start. So our adrenal gland is a pyramid-like shape, as you can see in our illustration. And you can also see that its location is just found above the kidney. So it is composed of distinct but conjoined glands. And for its anatomy, we have two areas. We have the cortex and the medulla. So the adrenal cortex is found in the outer region, which appears yellow, and it is the major site of steroid hormone production. For the adrenal medulla, it is found in the inner region, and the color is dark mahogany, and it is the major site of catecholamine production. So please take note that cholesterol is the parent cell of all steroid hormones. So we are already talking about the cortex, steroidogenesis. So actually, it all starts in your CRH because your corticotropin releasing hormone stimulates release of your stored ACTH or adenocorticotropic hormone from the anterior pituitary gland. So this ACTH will stimulate the transport of free cholesterol into adrenal mitochondria, initiating steroid production. So take note also that only free cholesterol, as what I have mentioned, no, only free cholesterol can be used or utilized to produce steroids. So once your ACTH is released, it will stimulate the secretion of adrenal glucocorticoids and androgens, and that is, of course, under the control of your hypothalamic CRH. So in addition to ACTH, your acetyl coenzyme A can also be utilized for additional source of cholesterol. So if the ACTH is the stimulatory substance or hormone for our steroid production, it is your LDL that serves as a negative feedback. So it is an inhibitory substance. Now your LDL is our low density lipoproteins. Okay, so this LDL acts as a negative feedback, meaning if there is already enough steroids, then your LDL would come into action by inhibiting further production of steroids to avoid overproduction. Okay. So it is in the mitochondrial membrane. Okay, it is in the mitochondrial membrane that your steroidogenesis happens. So this is where our conversion of cholesterol happens, no? Conversion of cholesterol pregnenolone. Okay, so pregnenolone. So what happens during that process is that 6 carbon atoms are removed from the cholesterol by the enzyme cytochrome P450 or P450. So the cholesterol, take note that the cholesterol here should be a free form cholesterol. So it will now enter our mitochondria. And inside the mitochondria, what happens is that your pregnenolone will be produced. So take note that the conversion of cholesterol to pregnenolone is a rate-limiting step in steroid biosynthesis. Ibig sabihin po that the amount of our steroid produced will be basing on the available pregnenolone. Okay? So as you can see in our illustration, it all starts in the hypothalamus. Your corticotropin releasing hormone will stimulate production of your ACTH, and your ACTH now will facilitate the free cholesterol so that it will be converted into pregnenolone, which is the rate limiting factor of steroid biosynthesis. So our cortex has 3 zones. Okay. So in each of these zones, they have different products. So for the G zone, we have the aldosterone production. For the F zone, we have the cortisone production. And for the R zone, it's the estradiol. So your G zone is functioning or participating in maintaining blood pressure and your serum potassium. Your F zone also participates in blood pressure maintenance and also glucose. And your R zone is for virilization or for your sex hormones. So again, now we have the G, F, and R. So G stands for zona glomerulosa. It is found in the outermost layer, and it is responsible for mineralocorticoid synthesis and also in maintaining our salt content. And then zona fasciculata, the middlemost layer, it is responsible for the glucocorticoid synthesis and also for sugar um, maintenance. And then we have zona reticularis in the innermost layer, responsible for the androgen synthesis and for the sex, of course. Now that would mean it is also responsible for our sex hormones. Okay. So let's talk about the different hormones produced by our adrenal glands. So first we have the aldosterone. So aldosterone is the most potent mineralocorticoid. Its main function is to help regulate water and electrolyte and blood pressure. So it actually increases retention of sodium and chloride and excretion of potassium and hydrogen. So your sodium and potassium has an inverse relationship. So um, if there is in every retention of sodium, there should be excretion of potassium. So take note that both of them are positively charged. No, so whenever there is a retention of a positively charged molecule, then there will be excretion of a positively charged molecule. So in the case of sodium potassium, when there is retention of sodium, there will be excretion of potassium, no, as well as your hydrogen ion. And we have here your 18-hydroxysteroid dehydrogenase. It is an enzyme needed for the synthesis of aldosterone. So aldosterone is actually controlled by renin-angiotensin system. If you can still remember your RAAS, it is very sensitive to water content, no, because water content is equivalent to blood pressure. So when we have low water content, then there is low blood pressure. So whenever there is low blood pressure, your renin will be activated, or the renin-angiotensin system will be activated, which will result to the stimulation of the production of your aldosterone, because again, aldosterone increases retention of water through retention of sodium, because keep in mind that where sodium goes, water follows. So if we have increased sodium retention, water will also be passively retained. Okay? So the inhibitor of your aldosterone, okay, the inhibitor of your aldosterone is are progesterone and dopamine. And for the suppressors, we have the ANT, intracellular calcium, ketoconazole, ACE inhibitors, NSAIDs, and heparin. So method for assay would be RIA and chromatography. Okay? So we have here, no, aldosterone is found in the G zone. Okay, so main steroid is aldosterone. The main regulator is the RAS, or the renin-angiotensin system. And the major function would be blood pressure and potassium homeostasis. So syndromes related to aldosterone, we have hypoaldosteronism and hyperaldosteronism. Okay, for hypoaldosteronism, our clinical findings would be hyperkalemia, renal salt wasting. And for hyperaldosteronism naman, HTN, hypokalemia, and metabolic alkalosis. Okay, so let's talk about the primary hyperaldosteronism. It is otherwise known as Conn's disease. So it is caused by aldosterone secreting adrenal adenoma. So there will be increased aldosterone. So there will be decreased renin. So there will be hypertension, hypokalemia, and mild hypernatremia, which results to metabolic alkalosis. Okay, so screening test, we have the PAC-PRA ratio. So more than 30 is suggestive of primary hyperaldosteronism. More than 50 is diagnostic of primary hyperaldosteronism. So we also have different diagnostic tests for primary hyperaldosteronism. We have the saline suppression test, oral sodium loading test, fludrocortisone suppression test, and the captopril challenge test. So let us focus on the saline suppression test. So there will be infusion of 2 liters of 0.9% saline over 4 hours, or by administering 10 to 12 milligrams of sodium chloride tablets daily for 3 days. Positive result would be more than 10 nanograms per DL of your PAC. No, so that's how we know that we have a primary hyperaldosteronism. Okay, so by the way, PAC means plasma aldosterone concentration. Okay, and PRA stands for plasma renin activity. So that's why we have the ratio PAC-PRA, or the plasma aldosterone concentration and plasma renin activity. Okay, so take note of that one. So next, we have the secondary hyperaldosteronism. So it is due to excessive production of renin. Remember that if there is increased renin, there will be increased aldosterone, because again, RAS is a regulatory system for your aldosterone production. So these are the associated disorders. So we have Liddle syndrome, or the pseudohyperaldosteronism. It is a congenital disorder that is characterized by increased epithelial sodium channel activity in the collecting duct in the absence of increased aldosterone. No, so kahit walang um increase ng ating aldosterone, there is increased epithelial sodium channel activity. So meaning increased yung salt retention natin. So for Bartter syndrome, it is also otherwise known as bumetanide sensitive chloride channel mutation. So it is a potassium losing autosomal recessive disorder, and there is a defective sodium chloride reabsorption in the thick ascending limb of Henle. So there is increased renin in response to a defect in the sodium reabsorption. So increased renin will result to increased aldosterone. And then we have the Gitelman syndrome, or the thiazide sensitive transporter mutation. There is also a defect in sodium chloride reabsorption that occurs in the distal convoluted tubule. And in this case, we have an increased aldosterone. Okay, so we have here primary aldosterone, high and low. So sa high, we have the following syndromes. Okay, so primary aldosteronism, aldosterone adenoma, adrenal hyperplasia, glucocorticoid remediable, glucocorticoid receptor defects, and adrenal carcinoma. So there will be low effective blood volume, there will be renal artery stenosis, hepatorenal syndrome, renin-producing tumor, salt wasting, and fluid loss. So in here for the PRA, we have here your plasma renin. Okay, yeah, plasma renin activity. So low renin, HTN. Okay, there will be salt retention, mineralocorticoid excess, glucocorticoid excess, 11-dehydroxylase deficiency, licorice ingestion, and Liddle's syndrome. For the high PRA, we have hypokalemia, stress, upright posture, and high renin, HTN. Now, so HTN here actually means hypertension. Okay, so hypertension. So we have here isolated hypoaldosteronism. It is due to the destruction of the adrenal glands. So of course, if our adrenal glands are destroyed, then there will be hypoaldosteronism. It will result to hyperkalemia. Bakit? So since you don't have aldosterone, there will be no retention of sodium, meaning there will be no excretion of your potassium. So there is hyperkalemia now, and metabolic acidosis. So tests are furosemide stimulation test or upright posture, and saline suppression test. So mineralocorticoid deficiency can lead to hyponatremia caused by increased renal sodium loss.